For the fourth Saturday Math Counts meetup, we're going to be looking at uh, abstract chess. We're not really going to be focusing on chess itself as a game because chess is a very, very mathematically complex game that would require way more than 2 hours to cover all the concepts that chess brings or has ever brought to mathematics. So, specifically, I'm looking at some problems that I got from this book, Across the Board, by John J. Watkins. But I'm not really diving deep into many problems. I'm just using some of the problems from this book. For example, I sent a problem out back at the beginning of April, talking about Giuliani's problem. Giuliani's problem gives us a 3x3 chessboard to work on, and our basic goal is to switch the knights. I've got it set up here with white knights up here and black knights down here. Now, as anybody who's played chess might be aware of, the knight moves in a unique sort of L-shaped way. So what the problem is within this 3x3 matrix, the idea is to swap the black pieces with the white pieces to the other side of the board, right? But you can only move using the Knight's Tour. Using the Knight's move. Knight's Tour is much farther down. But for so the idea is using the unique L shape. How do you do that? I'll give you a moment to think about it, and then I'll show you the actual answer for this. Okay. So it's a fun little puzzle to solve using a chessboard. That's why I decided to actually film myself doing this and putting it up. Because the solution's really just a sort of ring, right? And just have the knights follow each other. So this one moves first. Oops. This one moves first. This one moves first. Second, third, fourth. So there's one rotation. The second rotation would be 1, 2, 3, 4. Because remember, they're moving in this L shape. And then, so that was the second rotation. So now we're on the third rotation. And now for the fourth and final rotation should be the swap. Oops, right there and right there. There you go. And there is the 4 rotations needed to solve Giuliani's problem. Now, it's really interesting, and I'll leave this here for right now, but I will bring this up in my next email or video that I'll put out tomorrow. But there is a way there's a way that you can demonstrate a similar sort of concept using matrices and permutation matrices, because what's kind of great about the book across the board is it's a really good introduction to linear algebra and rotations using matrices. And also it also has a really great introduction to graphs as well, because this is something you can think about with this video as well, is like, so how do you represent something, the series of 4 rotations I just did, like how do you represent that as a graph with each night, right? So you can represent each place it goes as the actual nodes on the graph. Yeah, and then you can unfold that graph and it becomes a ring. But yeah, I will put out some more stuff. First, I just want to talk about the beginning of this puzzle and start talking about the actual problems that we're sort of working on. And this might be a little experimental with me doing some more video stuff to talk about.